I hope you are still enjoying your Python fundamentals. You will now learn about indentation, how to apply it, and why it's important in this Python language. Indentation is a very important concept of Python because without proper indentation in the Python code, you will end up seeing an indentation error and the code will not get compiled. That is a major issue. What exactly is indentation? Python uses it to highlight the blocks of code. Whitespace is required for indentation in Python. All statements with the same distance to the right belong to the same block of code. If a block has to be more deeply nested, it is simply indented further to the right. In simple terms, indentation refers to adding the 4 spaces at the beginning of code line. Similarly, for each level, 4 spaces are added further. But it brings the question, is it even necessary? Python uses indentation to indicate a block of code. Well, a block is several lines of code having the indentation at the same level. Take a look at the meme card, which shows a developer checking indentation with a scale to avoid making a mistake. Isn't it amusing? Let me explain this with an example. The expressions print and for are separate. They are the owner statements. As a result, they are aligned in the same level. The if statement is now controlled by the for statement. To do so, you will need to add 4 spaces. Following this statement, the if statement controls the subsequent statements. For indentation, you will need to add 4 more spaces. All statements within the if statement must be aligned. Then this print represents the end of the if statement and the following print represents the end of the for statement. If there is no indentation, Python has no idea which statement to run next or which statement goes to which block. The flow of execution is guided by indentation. I hope you have understood the concept. We will learn about data types such as numbers in this module. But what exactly does data type imply? Data types are the classification or categorization of data items. It represents the kind of value that tells which operations can be performed on a particular data. To begin with, there are multiple data types such as numbers, strings, and booleans. So let's start with the numbers. What are numbers? There are 3 kinds of numeric data types such as integers, floats, and complex used to represent the number. Let us see the first numeric data type, integers. Integers are numbers. It can be either positive, negative, or 0, but it cannot have fractions or decimal points. For example, 50, 0, -2 are treated as integers. We can perform simple calculations with integers such as addition in this example. 6 plus 4 results with 10. 1 plus 2 plus 4 plus 10 minus 3 results with 14. Print 1 plus 2 plus 3 plus 4 plus 5 plus 10 results with 25. Second is float. Now what is the float data type? Float data type is similar to integers except that float data types will have a decimal point. For example, -3.2, 0.0, 4.5652 are treated as float data types. Note that the decimal component can be 0 such as 0.0, or you tell your height in decimals such as 5.3 feet. The third numeric data type is complex numbers. Complex numbers are constituted by 2 numbers. They are represented as x plus yj. They consist of real and imaginary parts, where x is a real number and y is an imaginary number. The real imaginary part can be an integer or floating point. In engineering and research, complex numbers are extremely essential. Control theory, signal analysis, relativity, and fluid dynamics are just a few of the fields where they are useful. In upcoming modules, we'll conduct some interesting activities using numbers.